this talk, I will be presenting how these two open source technologies can help on building data pipelines. So a bit about the past. I'm currently a staff engineer at Astronomer, but I've worked for many companies in the last 20 years. And one of the companies I worked for was the BBC. And in 2019, the BBC had a proprietary recommendation engine that we had to replace. So the BBC was spending a lot in this contract. We didn't have the know-how of how the recommendations were happening, and we wanted to replace. And my team was targeted to replace the recommendation engine of BBC Sounds. By the time, we had the editorial team embedded in the team to make sure we were respecting BBC guidelines and editorial principles, having unbiased recommendations and all. And in parallel, we of course tried to have some objective metrics, such as some A/B tests and multivariate tests, so we could compare how the recommendation engines we were building in-house compared to the third-party provider we were building. And then we had a team at the BBC who would do analysis. So they would check how well the recommendation engine we were developing, we were just using open source, by the way, to develop that engine, was performing in comparison to the other ones. And then this team of analysts would create reports like this one saying, well, what we noticed when comparing these two variants, there was an increase for this age group on mobile phones, and then it would guide our decisions if we were going on a good direction or not necessarily so promising direction with the recommendation engine. That was the first time, I think, throughout my 20 years working with software engineering, that I interacted a lot with analysts, SQL analysts, people who had more experience doing SQL than I. And in one of those sessions, I was talking to an analyst, and he said, there is something weird in this report. And then I checked and said, yes, it looks like there is a bug. And then he said, oh, could you come here to have a look so we could brainstorm on what may be wrong? I said, okay, let's have a look. And then when he shared his working process, it felt like this. It was super messy. And I'm not the most organized person, but it felt really unhealthy, unsafe, and really, really messy. So what I saw that was happening was, the analysts, they would have like a Microsoft Word document where they would paste some SQL queries they had. They would copy and paste those SQL queries, put it in, let's say, Snowflake UI or someone else, run the query, download a CSV, modify the query again, run some query in another database, join the results manually in spreadsheets, and things felt out of control. So it wasn't surprising that there were some bugs because the process was quite fragile. So it really felt like an insect house, just waiting for bugs to show up. And by the time I was quite shocked because it was completely different from what we were experiencing when we were developing the recommendation engine itself, where we had lots of criteria. We had to have things reproducible, trackable. If a recommendation engine was misbehaving, we had even to track back which data was used to train that machine learning model so it could be audited. We had to have automation tests automated, unit tests, integration tests. No PR would emerge without code reviews. We had documentation, CI/CD, just the basic principles. And nothing of that was in the analyst part. And the funny thing is, we were making business decisions based on those analyses. So it felt we had to do something. By the time, these were some of the technologies we were using: Alpine Linux, Git, Python. We adopted Apache Airflow as one of the orchestration tools, Apache Beam as well. We were using Docker, PyTest, Kubernetes, and other things. And by the time I was thinking, we seriously should do something about how analysts are doing things in the org. But I didn't have much time to work on that by the time. So this is to give an idea of the sort of pipelines we were building by the time that are quite common in the industry. So we had some ETL to process, let's say, user activity, content metadata. We would use those data streams to train machine learning models. We would have artifacts. We would pre-calculate some of the predictions and output those. And this is an example of pipeline we had at the BBC by the time using Apache Airflow. So we could visually see the steps. We implemented them with Python. Everything was source controlled. If there were issues, we could retry, and things would just work. We had visibility, notifications, and everything. Time passed, and I got very attached not only to Apache Airflow, but to the community. And I ended up becoming a part of the community, and I was invited to work at Astronomer as an open source contributor to Apache Airflow. To those who don't know the project, it has 25 million downloads per month. It also has 3,000 contributors at the moment and growing. It's the project under the Apache Foundation who has the most contributors. It's a very active community. And Astronomer is one of the companies behind the project. So not only Astronomer has a hosted version of Apache Airflow, but we really invest in maintaining the project. So the Astronomer is responsible for all the releases, and we contribute around 55% of the code. And some of the top commuters, most of them are from Astronomer, and so on. And while working for Astronomer, we were analyzing the survey results, seeing where we could improve user experience. We figured out that one of the most common technologies that people would use pipelines in addition to Airflow was dbt. dbt felt exactly the right tool that the analysts could be using back a few years ago at the BBC. So it was basically a CLI that was built to really support analysts in building more sustainable projects with SQL. So it basically offered the transformation of ETL steps. It is a very mature open source project. It has 20 million downloads per month, over 300 contributors. And basically what dbt offers is, it allows people to define the SQL into, let's say, TXT files. It encourages people to use Git or other versioning control. It also encourages users to define very easily tests for those things. And then it encourages people to have, let's say, one model per file, and then it builds a pipeline so people can visualize their things and have some documentation very easily. It's under Apache license. And dbt Labs, the company behind dbt Core, this tool, has a business on top of hosting those pipelines. And one of the challenges is it is quite locked in. There are no competitors. And they've recently changed their licensing to charge per developer in the team, which made many people want to continue using dbt Core, but wanting to have an alternative to host their pipelines in production. That's where we see this joint between Apache Airflow and dbt Core, in the sense that Apache Airflow is this open source and reliable orchestration tool, which is maintained by Apache Foundation. It has many big players and companies behind it. It is very flexible, but it's more complicated to use, and we wanted to see a strategy of exposing dbt efficiently, leveraging the production power of Airflow, and the fact that Airflow is not vendor locked in. You could be using a managed version of Airflow in Google Cloud, in AWS, in Azure, or you could manage Airflow yourself. So you would have a full open source stack. So to connect both these things, we thought, how could we translate these dbt pipelines into something that Airflow could allow users to have the same visualization? And we built this tool called Cosmos. So Cosmos basically allows the mapping from one-to-one, one dbt model, one SQL transformation to one Airflow task. It is under Apache 2 as well license. It's on GitHub. For people to leverage, the interface is very simple. You can just write a simple DAG that represents a direct acyclic graph in Airflow, and you can mention which is the path to the DBT project you want to render in Airflow, and then it will dynamically understand the DBT project, define the topology of each, and then render that in Airflow and execute in Airflow as well. There are a few features that Cosmos offers that I think, given the experience of the audience with DBT and Airflow, I won't get into details. But some things that are interesting to see are, for instance, the adoption. So we've been seeing an increasing adoption of Cosmos over the last 1 year. So initially, there were multiple open source tools to try to do this glue between DBT and Airflow. And more recently, since November 2024, Cosmos really skyrocketed as the most popular tool. We have over 13 million downloads per month, over 800 stars in GitHub, and we have over 120 contributors on GitHub, which is really exciting. So, given the title of my talk, I want to have at least one slide summarizing how I would recommend people to try to productionize some data pipelines. So if you have SQL transformations, give DBT Core a try. If you would like to implement pipelines that are general purpose, you could try Apache Airflow. If you want to integrate both, you could try out Cosmos. There is also another open source project to run all that stack locally called Jasper CLI that can be quite handy. If you want to remain all open source, you can manage your own production deployment. We even released an open source Helm chart for Airflow. But if you want a company to help you with the deployment, Astronomer is one of them, but Google, Azure, and Amazon are there as well. These are the repos. I will be sharing the slides later, so you can try those things out. I don't think we will have time for the demo, but let's see. We have? Okay, so just to give some credits, these are some of the faces behind the project. And the maintainers are these. 1/3 of the maintainers are actually from outside of Astronomer, and we really want to increase this to make sure the project lives and continues outside of the scope of the company. So I have here an Airflow running locally. The way the project looks, you can see the DAG code is available here. We can see it's very similar to the example I gave. We reference in this code a DBT project, that's Jaffa Shop, that's a common example from DBT. We can either set schedules. Those schedules can be interdependent between multiple workflows, so trigger this workflow. If this workflow is finished running, it can be Chrome-based schedules. In this case, I'm manually triggering. You can see the tasks being executed. The tasks will be executed in a distributed manner. The deployment behind this can vary. You could be using Kubernetes. You could be using Celery executors, which may be running Kubernetes or not. So it is quite scalable. And then, based on this, you can see the success of the tasks. If you want to see the whole topology of the project, you can see how your DAG looks like. You can see we're running transformations and also running the tests that were defined with DBT. If the user wants to check, but what does that task mean exactly? Because the original user defined things using SQL, for instance. So we allow people to visualize what was the SQL executed in that transformation. And then, I don't know if I have in this example. Let's see. No, I think I didn't set. OK. We also allow visualizing DBT documentation inside. In this case, the DAG was fully successful. So you can see all the things. You can see these data sets that were generated that can be used to trigger other pipelines. You can inspect logs. You could define callbacks if you want to do other things with what is running. See the whole log of what should have run in DBT. And yeah, so this is becoming a quite established approach. At the moment, we have over 80 customers at Astronomer who are using this sort of setup. Hundreds of them are using Airflow with other integrations and things. Yes, so that was what I had to share with you. And now I'm open for questions if anyone has any question. Thank you very much.